Hello, my name is Ahmed Mikky. I'm a NASA NJSGC intern, and today I'll be presenting my semester-long research that I conducted with my professor over the course of, of several months. On my poster, you can see my name, my advisor, my college, and my email if you wish to email me for any concerns or questions. So my research is titled Variables that Impact the Ability to Run on Incline. And this included me trying to find the relationship between variables when it comes to running on an incline. Since the beginning of time, humans have generally been great runners. But since then, we have transitioned from hunters and gatherers to using vehicles to go from one place to another. This then led me to research what makes certain people better at running than others, specifically on an incline. The research required subjects from the New Jersey area. It included 55 subjects, 17 female and 38 male. From then, we began to collect data on them, including their jump height, their age, their duty factor, their contact time when running, their flight duration when running, and many other factors. From the data collected, statistical applications were put in place to see if there was any variables that had any significance between them. So this included making tables, graphs, frequency distribution, standard deviation, and t-tests. So there's a lot of data that we collected. So we organized into tables, and from those tables started doing tests and statistics. So the first one being the mean and standard deviation. So mean and standard deviation, what standard deviation indicates is how far measurements are from the mean. So how scattered the data is. Then we went on to using the frequency distribution. So this was mainly used when making graphs. So 3 of these are frequency distribution graphs, and they basically show how frequent a certain variable is in a sample. And we also, another type of graph used was an XY graph. So we related one variable to another. So this was age range versus incline level distance ratio. Finally, we used the t-test. So t-tests, basically using Excel, they show the significance between different groups. So if we wanted to compare one group with another, we would use a t-test to see if there was any significance between them. So in conclusion, we found that using the frequency distribution graphs, we found that there were few subjects in the older age groups. So what I'm talking about is between the ages of 58 and 66, there was barely 2 subjects that were in this age group. Compared to 18 to 26, there was around 21. So roughly there was half that dropped from here, and it kept decreasing and decreasing. So maybe in future research, we want to add more people in this older age group, just to see if there was any significance here. Also, we found that there was, for the level distance, for different graphs, there was different shapes. For example, level distance, we found it to have a bimodal shape, while incline distance had a positively skewed asymmetrical shape, basically just decreasing. So for incline distance, it's basically how far a person would run. So the further along the people would run, the more likely that they would quit. But for level distance, we found it increasing, then decreasing, then ever so slightly increasing a little bit, then decreasing again. So there would be 2 humps. So generally, the males had greater running distance, better running distance. But for everything else, generally it was the same for both male and female. But the most important thing we found was that there was a negative correlation between age and incline level distance ratio. So it was highly significant. It had a p-value of 0.023. So as you can see from this XY graph, that it was negatively correlated. So the older the individual was, the lower their incline level distance ratio was. And hopefully with future research, we can maybe see if there's more than just this type of significance if we were to get more older individuals. Thank you so much for listening.